Hello there. Today we're doing find minimum in rotated sorted array. So we're going to look for the minimum number in a rotated sorted array. So let's check this out. In this particular problem, we are given, let's say, this particular rotated sorted array. So it's in some sorted order. And we need to do this in log n time. So essentially binary search. So in this particular binary search, what we're going to do is we have a left and right pointer. And we're going to find the side that is smaller. So let's check this out. Suppose we have m at 7. That means let's check this middle against the right. If the middle is less than the right, that means to us that the smaller side is actually on the right side. And that means we can move the left to m plus 1. Now, we're going to see that when m is in the middle, less than the right side, that means we're in the side where the small number exists. And therefore, we can reduce r to r minus 1. Now we have middle here, and we can search through the entirety of this item and to get a smaller item. To get a smaller item, and move left down until we get to L equals 0, right? And that's it. Let's suppose our M is here, like at 1. Well, what happens here is, well, left is now 6 because M plus 1. Is it still less than? Yes, so what do you say, 8? Still 4. We move the middle to here, and that means we check this as our middle, make sure that that is our smallest item, and we move left up. And we now move, we move right, and then that means we get middle here, and we move right to past left, and then we end our loop. And that's how we do this particular problem. So let's check it out. So left, right equals 0, length of nums minus 1. So while left is less than or equal to right, if, let's get the mid first. Mid is equal to left plus right divided by 2. If nums mid is greater than nums right, that means we're left to mid is larger. Every item is going to be larger than everything on the right side. Right side of m. So left equals m plus 1. Otherwise, we are in the side where all the items are smaller, and smaller than the right side. That means we're in the in-order state, like 0 through like 7. If we're in this state, that means all we have to do is reduce right by half every single time until we get to 0. So let's say mid is now 7 divided by 2 is like 3, and then we just have to reduce, and then mid is now at 2. Now it's at 1. Now it's at 0. See? Now it's at 0, and we get our mid. Check it every time, right? Right equals mid minus 1. And also, we need to check one more thing. Well, actually, we can do this later. Here, min num is equal to the min of min num and the nums at mid. We need to get min num up here. Just give me a moment. Min num equals nums at 0. All right, with that, we can return min num. And with that, as we get this min num, right is equal 1 less than the last number, and we're good to go. Yeah, that's it. And let's run the code, check it out, and see what we get. Run the test cases, and submit. Perfect. This is a little slow right now, but it's gonna be it's gonna be much faster. Oh, what's going on? Let's submit one more time. I don't know what's going on. Okay, now it's fast. Sometimes it's slow, sometimes fast, but you can see that it's fast and slow sometimes. But depending on the type of questions that we're given. But that's how we get the minimum number in a rotated sorted array. If you have any questions, please comment below. If you enjoyed this video, like and subscribe. Want more videos, check the link in the description below. Thank you very much, and I will see you in the next one.